Hi, everyone. Today we'll be presenting our project on global COVID-19 evolution. Now, first, for a little bit of background, there are many COVID strains, but three most prominent ones were Alpha, Delta, and Omicron. Alpha first emerged in November 2020 in the United Kingdom. This variant was 30 to 50% more contagious than the original SARS-CoV-2 strain. Next, Delta was discovered in India during late 2020. It is almost 80 to 90% more transmissible than Alpha and more deadly. Lastly, Omicron emerged in Botswana during November 2021. This variant is characterized by more than 30 mutations in the spike protein. Clearly, over time, the SARS-CoV-2 virus has evolved to become more contagious and deadly. So here is a brief figure that shows stages of viral transmission. Most importantly, there are many evolvable traits that are linked with specific variants, like genetic changes in the ACE2 receptor, cleavage of the spike protein, immune escape, and other factors. And these can basically lead to viral evolution and many genetically distinct COVID strains. So our overall motivation behind this project is to dive deeper into COVID-19 evolutionary trends and understand how these three variants spread throughout North America, Europe, and Asia. Our overall big question is, how did COVID-19 evolve and change around the world?
What we have here is a figure from a paper that talks about the emergence of SARS-CoV-2 in North America. And ultimately, what they were looking at in this paper was similarities in mutations in certain sites, because what they found was there were a lot of differences in this site that they were looking at, which was called the 17747 site. And ultimately, they wanted to look at different sites, and they found that there were some similarities between the mutations that were in these different sites. So ultimately, this figure represents the phylogeny of representative sequences for these different strains of SARS-CoV-2 in North America and its connection to the ancestral Wuhan strain. In this next slide, we can see the dominance of different strains during different periods of time. And so this is only in North America. This data is only in North America. And so what we see here is that in April, we have the dominant strain is the Alpha, and then over time we go into the Delta and then the Omicron. And so I think this also highlights the fact that there are different strains during different time points in North America, and the virus is also constantly mutating, and because of that, there are different strains that dominate in different periods of time.
This was the timeline that the WHO released for each variant. Obviously the more detrimental ones with the largest effects are seen in red, and the blue ones indicate a less severe variant, as we saw within a population. Maybe it was isolated to a certain geographical area. Alpha, I'm going to talk about alpha, beta, or alpha, delta, excuse me, and Omicron specifically, as seen in the European timeline. So alpha specifically rose in Kent, England, in November of 2020. So a little bit after the first reported cases, in general, probably from the Asian regions of the world. Delta was seen in March 2021, and this was seen pretty sporadically across the European Union. So there wasn't a specific region or country or city, town where they found the first cases, because it did arise very sporadically across the EU. And then Omicron is the one that we are pretty much dealing with in terms of vaccinations and what we see more specifically in modern times. And that was as early as November 19th in 2021, and the first cases were in the Netherlands. So it is interesting to see how the delay at which this timeline from the WHO had a slight delay of a month to 2 months for the detection in Europe. This could be for a lot of different reasons. It could be different testing parameters and practices and legislation that's passed in order to make it mandated or not. But it is interesting to see overall.
We next analyze the evolution of COVID-19 in Asia, and a radical polygenetic tree was developed to understand COVID evolution in Asia, and was found that Delta was a significant variant in the phylogenetic tree with three clades, 21B, 21I, and 21J. and a maximum divergence of 57 was observed, and the minimum was 54 for Omicron. In addition, a linear model of scatter plot was developed with regression line, and clusters of Omicron was observed. In this model, the dots representing Omicron are presented on the upper side of the regression line, and alpha and beta are located in the middle. In addition, a scatter plot was developed using the sampling date. The scatter plot shows a linear cluster with more dots representing delta in the second plot compared to African continent. And a divergence has been used to understand microbial diversity, which represents the splitting event of a variant into phylogenetic tree. The model observes the highest divergence event in Omicron clade 21L in Asia, and the lowest divergence event was noted in Iota clade 20F in Asia and North America. However, a maximum divergence event was found in Omicron in Asia and Africa. In both cases, the leading divergent event recorded in clade 21L of Omicron.
Okay, so for some rapid fire conclusions, COVID trends vary significantly across the world. Viral evolution is common and widespread. SARS-CoV-2 is a very good example of this. And there's so much more additional info in other continents that we unfortunately didn't have time to talk about today, but lots of COVID trends can be seen across the globe. Here's a bibliography from what we talked about today, and that's all. Thank you so much for listening to our presentation.